Hey guys, this is a quick video on reviewing perfect squares and what a perfect square is. All right, so a perfect square, we took our notes and we defined what a perfect square is, but I'm going to also write this in here. A perfect square is a number you get from multiplying any whole number by itself. All right, and the most important word in this definition is probably going to be itself. You are multiplying any number by itself. Okay, so let's review our Cheez-It lab activity. You guys remember the Cheez-It lab activity? We were making squares, and I asked you how to make the smallest square, and you told me that all I needed was this one square, right? Now, what makes this one Cheez-It square a square? Well, a square is a square when it has the same side lengths. Now, it does have 90-degree angles. Put myself down here. It does have 90-degree angles, right? But a rectangle also has 90-degree angles. It does have parallel lines for the side, but a rectangle also has parallel lines. So what makes this figure right here different than this figure? What makes it different from a rectangle is that the sides are the same length, okay? So we know that this right here, it is a square, and if we're writing down the side lengths, it's one Cheez-It high and it's one Cheez-It long. Okay, now if we had something like this, again, that's a rectangle. It's not a perfect square because it's one Cheez-It high, but now it is two Cheez-Its long. So that is not a perfect square, right? All right, so what if now I want to make the square that comes after this, a bigger square, right? So if I had this one Cheez-It, how would I make a bigger square? This one, that's not a square, right? That's a rectangle. That's not a square. This is a square, and let's check ourselves again. Why is this a square? It's a square because now it's two Cheez-Its high and two Cheez-Its long. It's still a square, right? And then we have 4 total Cheez-Its. So that is how we identify if a shape is a square, that it has the same side lengths. It's 2 Cheez-Its high, 2 Cheez-Its long, or it's 1 Cheez-It high, 1 Cheez-It long. Okay, and now this total number is also pretty special. Okay, this total number right here, this 4, is what we call a perfect square. Because if I gave you 4 total Cheez-Its, could you make a perfect square out of it? You could, right? Now, what happens if I gave you 5? Not 4. What if I gave you 5 Cheez-Its? Is there any place that I could put this 5th Cheez-It to make it a perfect square? Well, I see a square right here, but this is not a perfect square. It kind of has a chimney, right? What if I put it right here? It's still not a perfect square. What if I gave you 6? Could I make a perfect square with 6? Well, that's a rectangle, right? It's still not a perfect square. So 5 and 6 aren't perfect square numbers. Because I know if I give you that many Cheez-Its, you couldn't make a perfect square. But 4 is, because if I gave you 4 Cheez-Its, you could make a 2 by 2 square. 1 is, because if I gave you 1 Cheez-It, you could make a 1 by 1 square, right? So what comes after this? What if I were to make one more? Right? If I were to drag some more Cheez-Its out here and make one more square, that's not a square because it's a 2 by 3, but I could add another row on top. And I now know that this too is a square because it's the same height as it is long, right? So I'm going to go ahead and write this in. It is now 3 high and 3 long for a total of 9. Right? So now I know that 9 also is a perfect square number. Because if I gave you 9 total Cheez-Its, you could create a perfect square. Right? So it's not necessarily odd or even numbers. Okay, it is numbers that you get by multiplying any whole number by itself. So do you actually have to sit there and count how many Cheez-Its there are total? No, we noticed in class that you could multiply the side lengths, these 3s, you can multiply those 3s together to get our total up here. And that would work with any square. So that's why these numbers are perfect squares. Going back to our definition, it's a number you get from multiplying any whole number by itself. So if I did 1 times 1, I would have 1 total Cheez-It. 1 is a perfect square. Before, if I had a 2 by 2, if I multiply 2 times 2, I got 4. Well, 4 is a perfect square. If I multiply 3 times 3 and I got 9, well, 9 is a perfect square because I'm multiplying these whole numbers together to get that perfect square number. So something that I want you to see here, we have our multiplication table. We practiced this. We worked on this, right? Something I want you to notice, let me scoot this over a little bit, is where our perfect square numbers are located on the multiplication chart. So if I multiplied 1 times 1, so any whole number by itself, including 1 times 1, I would have 1. So where's 1 located in our chart? Right here. All right. What if I were to make a square a little bit larger? What about a 2 by 2 square? 2 and 2 gives me 4 total Cheez-Its, right? So 4 is also a perfect square. What about our next perfect square? Well, 3 by 3, 9. 9 is a perfect square. What's next? 4 times 4, right? So 4 up, 4 across, it's perfect square. I would get 16. And what you notice there, right? Keep on looking. What do you notice? Our perfect squares go down in a diagonally in our multiplication table. Why is that? Let's look here. This 1 is a perfect square because it's a 1 by 1, right? This 4 is a perfect square because it's a 2 by 2. This 9 is a perfect square because it's a 3 by 3. And you could do this with any number. So for this multiplication table, right, 16 is perfect square because 4 times 4. This multiplication table ends at a 10 by 10, but could you make it 11 by 11 square? You could. What about a 12 by 12? You could. All of those numbers are perfect squares. All right, so let's go over some possible questions on perfect squares. So out of these perfect squares, fill in the blank with the missing perfect square. So I already know that these are all perfect squares, right? And the first thing I want to do is go ahead and make an observation. Are these numbers getting bigger or are they getting smaller? Are they increasing or decreasing? Looks like these numbers here are getting bigger. So I'm just going to draw a little arrow here so I know that these numbers are getting bigger. Now, what times itself gives you 1? They're all perfect squares, right? So what times itself gives you 1? 1 times 1 gives you 1, and that's what my Cheez-It looks like, right? Just one Cheez-It. How about 4? What times itself gives you 4? 2 times 2 gives you 4. Remember, and now that's a 2 Cheez-It high, 2 Cheez-It long, square with 4 total squares. That's what that one looks like. And then we're missing 1. Now, I know whatever goes in this blank has to be bigger than 2 because my numbers are getting bigger. They're increasing. So my side length has to be bigger than 2. What times itself gives you 16? 4 times 4 gives you 16. And then what times itself gives you 25? 5 times 5. Right? So, and as you can see, they're all getting bigger. They're all increasing. And my missing side length, my missing perfect square is a 3 by 3 square, which would give you 9. Okay, so take a look right here. My side lengths, 1, 2, 3, 4, 5. They're all increasing. They're all going up. All right, so let's look at another problem. All right, same deal. Fill in the blank with the missing perfect square. So go ahead and make your observation. Are these getting bigger or are they getting smaller? It's like they're getting smaller this time. They're decreasing, okay? So what times itself gives you 100? 10 times 10 gives you 100, right? So that's a 10 by 10 square, side length's 10, 100 total Cheez-Its on the inside. What times itself gives you 81? Now it's decreasing, so whatever that side length is has to be smaller than 10. 9 times 9 gives you 81. 8 times 8 gives you 64, our blank. And then what times itself gives you 36? 6 times 6. All right, so now I know they're decreasing, so my blank must be 7 by 7 square, which is 49. So my missing perfect square is 49, right? And then take a look again. All of my perfect squares are decreasing, which means all of my side lengths also need to be decreasing. Another possible question is, looking at all these numbers, which ones are perfect squares and which ones aren't? All right, so we just went over this 100. What times itself gives you 100? 10 times 10, so that one is a perfect square. That one looks good. 10. Now 10's a great number, right? It looks really good, looks really promising. Is it a perfect square? Is there something times itself that gives you 10? I know that 2 times 5 gives you 10, but is that a square? Am I making a square? Is a 2 by 5 figure a square? Right? A 2 by 5 looks like this. 1, 2 long, but 5 across? That's not a square. That's a rectangle, right? So that's not even a square, so it can't be 2 by 5. That's why I need to think of, is there any number times itself, the same number twice, that gives me 10? No. So 10 is not a perfect square. How about 65? Let's see, 10 times 10 is 100, so it has to be smaller. 9 times 9 is 81, has to be smaller. 8 times 8 is 64. 64, but I have 65. So this is not a perfect square, right? If I made an 8 by 8, got 64, and I gave you one more extra Cheez-It for that 65, it'd be sticking off the edge. That is not a perfect square. How about 16? 4 times 4 is 16, so 16 is a perfect square. 1, that's easy. 1 times 1 is a perfect square because it equals 1. And then 121. 11 times 11 gives you 121, so that one is a perfect square. I hope this helps.